Continuation of the previous video. Environmental education and awareness. Environmental education and awareness are critical components of addressing environmental challenges and promoting sustainable development. These concepts encompass a wide range of educational strategies, activities, and initiatives aimed at increasing public understanding, fostering responsible behavior, and advocating for the protection and conservation of the environment. This comprehensive overview provides an in-depth look at environmental education and awareness and emphasizing their significance, principles, approaches, and impacts. So, significance of environmental education and awareness. Environmental stewardship. Environmental education cultivates a sense of responsibility and stewardship towards the natural world, encouraging individuals to protect and preserve it. Then, sustainable behavior. It promotes sustainable practices in daily life, such as reducing waste, conserving energy, and adopting eco-friendly habits. Then, informed decision making. Environmental education empowers individuals with knowledge and skills needed to make informed decisions about environmental issues, such as climate change, biodiversity loss, and pollution. Global citizenship. It fosters a sense of global citizenship, emphasizing the interconnectedness of the planet and the importance of collective action in addressing global environmental challenges. And policy advocacy. Environmental awareness encourages individuals to advocate for environmentally responsible policies and practices at local, national, and international levels. And principles of environmental education and awareness. Holistic perspective. Environmental education considers ecological, social, economic, and ethical dimensions, providing a holistic understanding of environmental issues. Then, experimental learning. Hands-on experiences, field trips, and outdoor activities are integral to environmental education as they deepen understanding and foster a sense of connection to nature. Interdisciplinary approach. Environmental education draws from various disciplines including biology, ecology, economics, sociology, and ethics to provide a multidisciplinary perspective. Then critical thinking. It encourages critical thinking, problem solving, and analytical skills, enabling individuals to evaluate environmental information and make informed judgments. And action oriented. Environmental education goes beyond awareness to inspire action. It motivates individuals to take practices and practical steps to protect the environment. Cultural and contextual relevance. Effective environmental education is culturally sensitive and relevant to the local context, respecting indigenous knowledge and traditions. And approaches to environmental education and awareness. Formal education. Environmental concepts are integrated into school curricula from primary to tertiary level through subjects like biology, geography, and environmental science. Then non-formal information or education. Environmental organizations, NGOs, and community groups offer workshops, seminars, and nature-based programs to educate the people. Then informal education. Informal settings like museums, botanical gardens, and nature centers provide opportunities for self-guided learning and exploration. Mass media and communication. Environmental awareness is disseminated through television, radio, documentaries, and social media to reach a whole wide audience. And citizen science. Engaging citizens in data collection and research projects promotes hands-on learning and contributes to scientific knowledge. Then impacts the outcomes of environmental education and awareness. Behavior change. Environmental education can lead to positive changes in behavior such as reduced energy consumption, increased recycling, and support for conservation initiatives. Then community engagement. It fosters a sense of community and collective responsibility for environmental issues, leading to grassroots initiatives and volunteerism. Then policy influences. Informed and engaged citizens advocate for environmentally friendly policies and hold governments and corporations accountable. Biodiversity conservation. Environmental education contributes to the protection of biodiversity by raising awareness of threatened species and ecosystems. Then climate action. It mobilizes individuals and communities to take action against climate change through carbon reduction initiatives and advocacy. Then sustainable development. Environmental awareness is integral to achieving the sustainable development goals, particularly Goal 4, quality education, and Goal 13, climate action. So, in conclusion, environmental education and awareness are pivotal in building a sustainable and environmentally responsible society. They empower individuals and communities to take meaningful action to address pressing environmental challenges, scholars, educators, policymakers, and environmental professionals must recognize the importance of these concepts and support their integration into formal and informal education systems. Moreover, understanding the principled approaches and impacts of environmental education and awareness is essential. Then, environmental ethics. Environmental ethics is a branch of philosophy that explores the moral dimensions of human interactions with the natural world. It examines questions related to the value of environment, the ethical responsibilities of individuals and societies towards nature, and the principles that guide ethical information. Then, decision making in environmental matters. So, foundations of environmental ethics. Anthropocentrism. Historically, many ethical systems placed humans at the center of moral consideration, valuing the environment primarily for its instrumental use to human well being. However, this perspective has evolved to encompass a broader ethical view, that is, anthropocentrism. That is the foundation. Okay, then next, biocentrism. Biocentric ethical extends moral considerations to all living entities, recognizing intrinsic value in non human organizations and ecosystems. So, philosopher Paul Taylor's respect for nature is a prominent biocentric theory. Then, ecocentrism. Ecocentric ethics takes a wider perspective. So, in case of biocentric ethics, moral considerations extends to all living entities, recognizing intrinsic value in non-human organisms and ecosystems. And ecocentrism is something which takes a wider perspective, considering the well-being of entire ecosystem as having intrinsic value. Aldo Leopold's Land Ethic and the work of philosopher Arne Naess are examples of ecocentric approaches. Key concepts of environmental ethics. Intrinsic value. This concept points that nature has inherent worth independent of its utility to humans. It challenges the view that the environment's value is solely instrumental. So, something contrary to this first anthropocentrism. Okay, then stewardship. Stewardship ethics emphasizes humans' responsibility to care for and protect the environment as stewards or guardians. It draws from religious and cultural traditions that highlight human duty to safeguard nature. Then sustainability. Environmental ethics often intersects with sustainable principle, emphasizing the need to ensure that human actions do not deplete resources or harm ecosystems in ways that compromise future generations' well-being. Then intergenerational ethics. This ethical framework underscores the moral obligation to consider the impacts of today's action on future generations. It highlights the importance of sustainable practices and resource conservation. And ethical dilemmas and environmental issues. Climate change. Environmental ethics plays a critical role in addressing climate change by exploring the ethical dimensions of greenhouse gas emissions, climate justice, and the responsibility of developed and developing nations. Then, biodiversity conservation raises questions about the moral imperative to protect species diversity and the ethics of habitat destruction over exploitation and extinction. Then, environmental justice. Environmental ethics examines the equitable distribution of environmental benefits and burdens among different communities, particularly those disproportionately affected by pollution and environmental hazards. Then, resource allocation. Ethical considerations inform decisions about resource allocation, such as water use, land management, and the distribution of natural resources. And prominent environmental philosophers and theories. Aldo Leopold. Leopold's land ethic posits that humans should view themselves as members of the biotic community and extended ethical considerations to all elements of nature. Then Rachel Carson. Carson's work, especially Silent Spring. Rachel Carson highlighted the ethical concerns surrounding the use of pesticides and their impact on the environment. Arne Naess introduced the concept of deep ecology, emphasizing the intrinsic value of all life forms and ecosystems. Deep ecology advocates for radical shifts in human values and behaviors. Then ethical frameworks in environmental decision making. Utilitarianism. This approach assesses actions based on their utility or the greatest good for the greatest number. The environmental ethics it can be applied to evaluate policies and practices that maximize overall environmental well-being. Then deontology. I'm not sure about the pronunciation. Deontological ethics found on moral duties and principles. In environmental context, it may emphasize adherence to principles like do not harm or respect the intrinsic value of nature. That is deontology. Then virtue ethics. Virtue ethics emphasize the development of virtuous character traits in individuals and societies. It may encourage environmentally virtuous behavior such as conservation and responsibility. Then environmental ethics in practice, conservation ethics. Ethical principles guide conservation efforts to protect endangered species, preserve biodiversity, and maintain ecosystems. Then corporate responsibility. Ethical considerations influence corporate sustainability practice, such as reducing carbon emissions, minimizing waste, and promoting environmentally friendly products. Then environmental policy. Ethical perspectives inform the development of environmental laws and regulations as well as international agreements like the Paris Agreement. Then environmental education. Environmental ethics underpin educational programs that cultivate ethical values, ecological awareness, and responsible environmental behaviors. So, in conclusion, environmental ethics is a dynamic field that addresses complex moral questions related to humanity's relationship with the environment. It provides essential guidelines and guidance for ethical decision making, policy development, and sustainable efforts. Scholars, policymakers, and environmental professionals must engage with these ethical considerations to navigate the intricate challenge of environmental conservation and stewardship. Then, environmental chemistry. Environmental chemistry, a comprehensive overview. Environmental chemistry is a multidisciplinary field that examines the chemical processes and interactions occurring in the environment. It focuses on understanding how chemicals move, transform, and react in natural systems, including air, water, soil, and living organisms. Environmental chemistry plays a crucial role in addressing environmental challenges, assesses pollution, and developing sustainable solutions. Then, key concepts in environmental chemistry. Environmental compartmentalization. The environment can be divided into compartments or media, including the atmosphere, hydrosphere, lithosphere, and biosphere. So, environmental chemistry examines the interactions within and between these compartments. Then, pollution and contaminants. Environmental chemistry studies the sources, fate, and effects of pollutants and contaminants, including chemicals, heavy metals, pesticides, and industrial effluents. Chemical reactions. It explores chemical reactions such as oxidation, hydrolysis, and complexation that occurs in natural systems and influence the behavior of pollutants. Then transport processes. Understanding transport processes including diffusion, advection, and dispersion is crucial for tracking the movement of pollutants in air, water, and soil. Chemical equilibrium. Environmental chemistry applies principles of chemical equilibrium to assess the speciation, chemical forms of elements and compounds in environment. Environmental chemical processes, air chemistry. Atmospheric composition, analyzing the composition of the Earth's atmosphere, including gases like oxygen, nitrogen, and greenhouse gases. Air pollution, investigating the sources and chemistry of air pollutants such as sulfur dioxide, nitrogen oxide, and volatile organic compounds. Tropospheric chemistry, examining chemical reactions in the lower atmosphere and their role in smog formation, acid rain, and climate change. And water chemistry, aquatic chemistry, studying the chemistry of natural waters, including freshwater bodies, for example, lakes, rivers, and seawater. Then water quality, assessing water quality parameters like pH, dissolved oxygen, nutrients, and contaminants to understand the health of aquatic ecosystems. Then soil chemistry, soil composition, analyzing the chemical composition of soils, including mineral components, organic matter, and nutrients. Then soil contaminants, investigating soil contamination by heavy metals, pesticides, and organic pollutants, as well as chemistry of soil remediation process. Then biogeochemical cycles, carbon cycle, studying the cycling of carbon through terrestrial and aquatic ecosystems, including photosynthesis, respiration, and carbon sequestration. Nutrient cycles, exploring the cycling of essential nutrients like estrogen, phosphorus, and sulfur, with the critical for plant and microbial growth. Analytical techniques in environmental chemistry like spectroscopy, UV visible infrared and atomic absorption spectroscopy are used to identify and quantify chemical compounds in environmental samples. Then chromatography, gas chromatography and liquid chromatography separate and analyze complex mixtures of organic compounds. Mass spectrometry. Mass spectrometry helps determine the molecular structure and mass of compounds, aiding in the identification of pollutants. Then electrochemical analysis. Techniques like ion sensitive electrodes are used to measure ion concentrations in water and soil samples. Environmental challenges and solutions. Air quality management, water treatment. Air quality management in the sense environmental chemistry informs air quality standards and strategies to mitigate air pollution, including the reduction of greenhouse gas emissions. Then water treatment, understanding the chemistry of water purification process such as coagulation, flocculation and disinfection improves water treatment efficiency. Then soil remediation. Environmental chemistry guides social remediation techniques such as phytoremediation and chemical immobilization to restore contaminated sites. Then waste management, it plays a role in the treatment and the disposal of hazardous waste, ensuring that pollutants do not harm the environment. Then environmental monitoring, analytical techniques in environmental chemistry are vital for monitoring pollutant levels, ensuring compliance with environmental regulations.